Greetings to everyone. Welcome back to Racket Media. And in this video, we are going to solve tutorial set 5 and prepare for the exams. So if you find this video helpful, kindly give me a like. And also, if you are new to this channel, kindly subscribe to the channel. Thank you. So, yes, I know the video will be long again. I know we have been complaining that the video is long. Yes, the video is long because the questions are plenty. If I'm to solve some and then leave some, then the video wouldn't be long, right? But if I'm to solve everything, then the video would definitely be long. So it's either you can put the video at 2x or 1.5x to reduce the duration for you. Aside that, I'm not sure there is any better thing I can do because I want to solve all. When you check this kind of question, for example, during tutorial, this was the only question that was solved. Yeah, I think one of them, they solve one and then they leave the rest for us. But I'm here to solve all. Even solving one of them and leaving the rest for us, they spend like 2 hours to solve it with us. Just imagine me also solving it here and all of them. So you should be expecting that the time will actually increase. But let's look at question 1, which is a likely examinable question, right? So your firm, Alpha Securities, has invested 50% of its funds in asset X and the remaining 50% in asset Y. Asset X and Y prices are given in the table below. So these are these are the prices for 2017, 18, 19, 20, 21, 22. And this is the prices for 20. This is the price of X, this is the price of Y, right? So based on the data given, the chief investment officer wants you to provide the following information. You find the expected return of these two portfolios. And if we want to find the expected return, then we also have to look for the arithmetic return, right? Before we find the expected return. So uh so when we find the expected return of assets X and assets Y, then we use it to find the assets return on the portfolio. Then the B is also there telling us to find the variance and the standard deviation and the rest. So let's do them one by one. And I'm going to teach you 2 ways. I'm going to teach you how to use calculator to get it easily, right? And how to also go about it in the mechanical way. This is because in exams, I asked the TE and then he said that in exams, we can use calculator and then go straight to the answer. But me, I'm afraid maybe when you go straight to the answer, you lose some maths. So I'm going to teach you both of them. And then you are going to choose the one that you think will be okay for you. So you should actually know that this video will be long. I can't also do it part 1 and part 2 because I'll not feel okay to come back. Maybe I'll feel lazy to come back here. So let's go. A is telling us to find the return on the 2 assets. So let me just put this thing here. Yeah, I'll be using both Excel and the writing. So here, price of X, price of Y, then we'll do something like, okay, let me do this. Then on X. Return Y. Right? And then we also look for return on x. So let me do it. Rx minus expected return on minus Rh. Also do something Ry minus Ry. Rx. All right, so let's just insert the years back. So it is from 2017, 2018, 2021. We have for assets, we have 100. Then let's come to price of assets y 200, 230, 460, 410, 480, and then 380. All right, so return on assets X, or the returns in 2017 is normally 0, unless they give you that, the investment started with an actual money. Let's say it started with like $80 in 2016. Then that one, you have to subtract it. We are coming to use the formula right now. You have to do that one and then um get the return on 2017. But since they started from 2017, the return on 2017 is going to be 0. And we are not going to include it in most of our computations. So let's begin. So if you want to find the return, you know, I went over it in the previous session. Return is going to be the new price over old price minus 1. That's if you want it in decimals. But if you want it in percentages, you can also multiply it by 100. Or you can also do it this way. New price minus old price all over old price times 100 if you want it in decimal. If you want it in percentage, multiply by 100. But if you want it in decimal, just leave it at new price minus old price all over old price. So this is the formula we are going to use. So when we take the first one, we are not getting, so for 2018, the new price is 120. So 120 over the old price, 100 minus 1, right? So right, so we are getting 0.2. Right, so you put here 0.2. We are going to do the same thing for this one, which is going to be y 2018 30 over 200 minus 1. Okay. And then now return on x 2019 is going to be 108 over 120. So you see, we want to do for 2022 to be 190 over 108 like that. So 108 over, we are going to get negative 0.1. Right. So in 2019, so this one negative 0. And here too is going to be 460 over 230 minus 1. So the answer is 1. Right. So you put 1 here. So the next one, this one is going to be equal to into brackets. I'm not coming to use Excel, so that's how I'll go fast. 190 over 108 brackets close. All right, so here it is going to be equal to 160 divided by t bracket close. And here it is going to be equal to bracket open 280 minus 160 divided by 160. That's it for that one. Here it is going to be equal to 410 divided by 460. So that is it for this one. So let's do the summation. So the sum the summation is basically adding all of them. So this is included 136. All right. So now this is the sum. This is the total here. Now after the totals, after we have the totals here, we have to find the arithmetic mean. So arithmetic mean of assets Y. Of X. So let me start from X. It's going to be the sum over N, right? It's going to be the sum over N. So when we check here, we only have 5 returns here, which is 1, 2, 3, 4, 5. We are not including the first years, right? We are not including the first years from the 2017. We're only calculating from where we started getting some returns, which is 2018, 2019, 2020, up to 2022. So that's what we are calculating here. So the sum for X is 1.45, and then the N is 5. Because when we count from 1, 2, 3, 4, 5, right? So that's why it is 5 here. So with this one, we are going to get 0.29. Now, to do the same thing too for return, we are doing the arithmetic return for assets X and Y. the return on the asset X and then the return on asset Y. So we do the same thing also here. Y is also going to be the sum over the n, which is going to be equal to 1/5 going to 0.2. So this one is also what 0.2. Right, so I will return here is 0.29 and then here is 0.2. Right. Now, if we want to find, okay, so let me put here Rx. The Rx. So let me say return on assets. RE, R, E. Yeah, so here is for assets X and then here is for assets Y. So here, if we want to get here, here is also 0 still. And then here, this one is going to be this minus this. So it's equal to R X minus R A X. This is it's going to be, you take the first one, right? You take this one, which is 0.2, 0.2 minus its arithmetic return, 0.29, 0.29. Then we are going to get 0.09 in negative, right? In negative. Now, if you also want to do for Y, the same thing. So this is for 2018. Y, Rx, Ry, sorry. Return of Y minus R A Y. Arithmetic return of Y in 2018 is going to be the same thing like the first one we just did. You take 0.15 minus 0.2. So it's 0.15 minus 0.2. We are going to get 0.05. And we are doing this because we want to find covariance and then correlation coefficients. If the question doesn't state that we should find variance and correlation coefficient, then we don't need to do this. So this is the mechanical way, right? Let me finish this quick and then teach you the calculator way. So now it's going to be equal to this minus the return. So let me put a reference on this, that this is what we are going to use throughout, so that I can just drag. Oh, I don't need to even come up to this side. I need to drag it up to here. All right, so we do the same thing for this one. Equal to the return on asset Y minus, let me cell reference minus the arithmetic return of asset Y. Let me cell reference it. This is the first one, like what we just solved. All right. So this is it up to this point, right? I hope you get it. So now let's move on to getting our expected return. Remember, the expected return is basically the weight of X times the return on X, the arithmetic return on X, and then the weight of Y times what the arithmetic return of Y. So expected return. We are not coming to answer the question. Expected return is equal to weight of X times return, the arithmetic return of S plus weight of Y times the arithmetic return of Y. We had weight is in the question that the alpha securities have invested 50% in asset X, which is the weight, and then 50% in asset Y, which is the weight. So 50% is 0.5 times the return, which we had as 0.29. The arithmetic return, we had it as 0.29 for X, and then plus weight of Y 0.5 times the arithmetic return of this one was 0.2. When we do this, we are going to get 24 0.245, which is equal to 24.5%. So that is our answer for the A. That is our answer for the A, the expected return. Now let's go to B. B is saying that compute the variance and the standard deviation of assets X and Y. This is where it becomes so plenty and then tough. So standard deviation of X is basically you taking the return on X minus the arithmetic return, you square it plus the next one minus this, you square it. So this is what it will look like. What's the first one here? 0.2 minus 0.29 squared plus the next one is negative 0.1 plus, sorry, minus 0.29 and you square it plus the next one, which is 0.76. So 0.76 minus 0.29 when you square it. So, okay, so this will start from we looking at for the variance. Right. So you do for all because of time. I can't do for all, so you can do the rest, right? And then you are going to divide all by n minus 1. N is 5, so 5 minus 1, right? So when you do it, let me see, you are going to get the variance to be equal to 0.1988. Then, because it's the variance, we want to get a standard deviation. You take the root, and then standard deviation is going to be equal to 0.4459. Right. Now, do it for the next one too. Of y. That will also be the same thing here. Take the return, you subtract it from the arithmetic mean, and then you square it. And remember, it is n minus 1 because we are using sample, right? If it is population, no n minus 1. So we're going to do the same thing here. The first one is 0.15, 0.15 minus 0.2 squared plus the second one, which is 1 minus 0.2 squared plus the next one, and it follows like that until you finish. Remember, n is still 5 minus 1. 5 minus 1. So in that, you are going to get the variance to be equal to, we're going to get the variance to be equal to 0.2264. And then the standard deviation, which is when we take the root of the variance, we are going to get 0.4758. All right. So now we've computed for the variance and standard deviation of assets X and Y. So here is T. That one is now B. B is saying that should compute, we should comment on the standard deviation of X and the standard deviation of Y. So we comment on the standard deviation of X and the standard deviation of Y is that, you see, standard deviation measures risk, right? And then we can see that the standard deviation of X is low as compared to the standard deviation of Y, right? So this tells us that asset X is less riskier than asset Y. You get it? So asset X is less riskier than asset Y because asset X has a what? A lesser standard deviation or risk as compared to asset Y. So that's going to be our comment here. And now let's move on to Let's go to E. E is saying that compute the covariance between X and Y. Right. So covariance between X, Y is going to be, see what we computed here. What we computed here. So this times this plus this times this plus this times this. So that's what we are coming to do here. So the first one, 0.09, negative 0.09 times negative 0. So negative 0.09 times, is it negative again? Negative 0.05 plus the next one, which is going to be 0.39, negative 0.39 times 0.8. So negative 0.39 times negative times 0.8 plus. So that's how you are going to do it. Then you divide all by n minus 1, which is the same as 5 minus 1, right? So you see, it just follows like that. So if you fail or miss one step, well, you fail or top or one calculating something here to affect everything, right? So that's what you are going to do. And then we're going to get a covariance. Because of the luxury of time, like I don't have that plenty time, otherwise the video will be too long. That's why I want you to continue from there. So when you continue, you are going to get a covariance of X and Y to be around negative 0.1593, negative 0. Something around this one. Also, you're going to get. So if we want to get the correlation, remember correlation has a formula of correlation is equal to covariance over the standard deviation of X times the standard deviation of Y. So when I'm coming to teach you the calculator trick, this is what we are coming to, this is what we are going to do, the covariance of X. The covariance of X and Y is what's negative 0.1593 all over the standard deviation of X is 0.445 4459 times the standard deviation of Y is 0.4758. And we are going to get something around negative 0.7510. Right, so that's what we are going to get for that side. Now, we solve for the correlation in the covariance. Now, let me about them. So correlation, covariance is E, correlation is F. The covariance is E, correlation is F. Now, what is the implication of the correlation between X and then Y? So the implication between the correlation of X and Y, let me see the correlation for profit construction, for portfolio construction. So the correlation here we are saying what is negative. And negative correlation means that they move what in the opposite directions. So this is actually very good for a portfolio construction because this is actually going to reduce the risk in that portfolio. If you have assets that move in the opposite direction in a portfolio, then the risk in that portfolio actually reduces, right? So that's going to be that the implication of the correlation here shows that they are negative. So they move in a negative direction, which is going to reduce the risk in the portfolio, right? So now it is saying we should compute the portfolio standard deviation. So portfolio standard deviation, which portfolio standard deviation, as we know, we did it in the previous session, right? Portfolio standard deviation is going to be weight of X times the standard deviation of X squared plus weight of Y times standard deviation of Y all squared plus 2 times weight of X times weight of Y times the standard deviation of X times the standard deviation of Y times the correlation of X and then Y. But correlation can also be computed this way. Say correlation. Covariance, sorry. Covariance is equal to the correlation of X and Y times the standard deviation of X times the standard deviation of Y, right, which is equal to this. So we can just replace here by what? The covariance. So in a question where we are giving covariance, you wouldn't need to write all this, right? You wouldn't need to write all this. But if you are giving correlation coefficient, then you need to bring all this. So now, let's go. All right. So weight of X is 0.5, as we know, and the standard deviation of X we solved up there. Zero 0.4459. Or is it 0. squared plus the weight for this one is also 0.5 because they divided the distance into 2 times. The standard deviation of that one is 0.44847. Right? Now plus 2 times the weight of x is 0.5 times the weight of y is also 0.5 times the covariance. Covariance, we solved it to be what's the covariance? Negative 0.1593. Negative 0.1. So we do all this and we are going to get 0.60, 0.0267. And that's the variance. If you want to get standard deviation, it's going to be retaking the roots both sides. We are going to get 0.1633. Right? So we're getting 0.1633. That will be the standard deviation of the portfolio. Now, they say we should do what? Comment on the standard deviation. So we can see that when the portfolios, when the assets were individual, no, their risk was 0.0459. Sorry. Their risk was what? 0.4459 and then 0.4758, which is actually higher than 0.1633. So you can see that when you put both of them in a portfolio, the risk is lesser as compared to you investing in them separately, right? So it is rational to invest in portfolio X and Y, as in put them in one portfolio instead of investing in them individually. Investing in the portfolio has a risk of 0.1633, which is less than the individual risk, right? So that's going to be our comment. Then J is asking us to assume you are told that asset Y represent the market return. Find beta of asset X. What does this beta tell you? So now this is for J. Normally, this is how we compute beta. Beta is equal to the covariance of X and Y all over the market return, right? So now they said we should, and the question is saying that we should let asset Y represent the market return, right? So market return is going to be the variance of asset Y. So variance of asset Y. Now the covariance will still come. Now, covariance, as we solved up there, is negative 0.1593, right? All divided by the variance of asset Y. You can check if you've written it in your book. You can just click it there. Variance on asset Y is 0.2264. 0.2264. 0.2264. And we are going to get a beta of negative 0.7036. That is beta. Now, so what does this beta tell you? Which assets are likely to exhibit the beta that you have computed or observed? So the negative beta actually implies that asset X moves in the opposite direction of the market, right? And assets like this rise when the market falls, and then the vice versa. So that is what it means there. So assets that are likely, they said, when I checked online, they said assets like this are like security bonds and the likes. So that is it for the question 1, almost 1 hour. And this is likely going to be a compulsory question for the distance. So now let's do this using a calculator. So here's the calculator. Now, before you do everything on the calculator, what I need you to do is to just compute the return on X and the return on Y. Just compute them. Now, you press mode. After computing, you press mode, and then you choose to restart. Then you choose 2. Now, you put in the return of X and then put in the return of Y. Let's put in the return of X, 0.2. Then you press equal to, then negative 0.1 equal to, then 0.76 equal to negative 0.16 equal to, and then 0.75 equal to. Now we are done putting them. You see, we didn't start from 2017. It is not part. We're only starting from where the return started here. Now let's also enter the figures for assets 9. So 0.15 equal to 1 equal to negative 0.11 equal to 0.17 equal to negative 0.21 equal to. So we've computed the returns for both of them, right? For both of them. Now, after computing the returns, and you want to find the expected return, right? Where you need to get the arithmetic mean. You need to get the arithmetic mean here. Press AC, press shift, then 1. Then you choose 4. Then the arithmetic return for X is going to be 2. So you press 2 equal to, so you see 0.29. 0.29 is here. If you want to get for Y, AC, shift 1, the same 4. And then 5 is for what? The return of 9. So 5 equal to, then you get 0.2 for the return of Y. So simple, right? So simple and then straightforward. Now, you use, you just put it in the formula that we use in computing the return, right? The expected return. Just put it in the same thing here, and then you find them, right? As you've done here nicely. So After doing that, you are going to get exactly the same thing here, right? So you see we had the same thing here, right? So now let's now want to find the standard deviation. Don't press on, never press on. We are still using the data we placed in there. So now we want to find standard deviation, right? We want to find standard deviation, which is this plain things here, right? You just press shift with the same data that has been keyed in the shift and then 1. Then you choose the same 4, right? If you choose 4, if you choose 4, you are going to get a standard deviation of x. And then when you choose 7, you are going to get a standard deviation. Don't choose this one, is choose standard deviation, but this is for population. And then the S1, they are who say S account here, sample. So sample for x. So let's choose for S4. So you see 0.44, approximately 0.4459. So you see it's here. Then meaning you are getting the standard deviation straight. If you want to get variance, right? Remember when we are coming down from variance to standard deviation, what we do is we take the roots, right? Now, if you want to go back to this one, then what we are going to do is we are going to what? Square it. So answer squared. So when we square it, then we get this for the variance. So simple. Now let's do the same thing for y. You see we are the way we are jumping steps if you are using calculator. So the same thing, the same data keyed in the shift 1, then 4, then 7. 0.47. 63. Wow. Okay, so I've done some slides, maybe, but it's still similar. So 0.4763. Let me correct it. It's because I was using mechanical. If you're using mechanical, that's what you are going to do. Right. Now, answer squared is going to give us 0.2269. Don't put it there too. All right, so you see we've gotten this so simple. We don't need to do plenty work. Now, when you compare the standard deviation, you're still going to see the same result. Now, we come to covariance. We can still use the same calculator to find the covariance, so easy. So now, instead of going through this plenty work, if you want to find the covariance, remember correlation is what's equal to covariance over standard deviation of x and standard deviation of y. If you want to get covariance, as I said earlier, covariance is equal to correlation times standard deviation of x and then standard deviation of y. Remember, we've already found standard deviation of x and y up there, right? So what we can do here is to use the calculator to find the correlation. So meaning that you're going to skip E and then do F, then you come back and then come and continue with E, right? With this strategy that I'm teaching. So shift 1, then you choose 5, regression. Then you choose R, which is the correlation. Just 3 equals get 0.7395. So 0.7396 approximately. So correlation is going to be 0.7396. Right, times the standard deviation of x, which we computed up there. Standard deviation of x 0.4459. 0.4763. 4763. That will be the covariance. Covariance of x and y. That's the answer we are going to get. So remember, this was negative, or this was negative 0.7. So negative 0.7396 times covariance is going to negative 0.1571 approximately. All right, so there's some slides listing here. Just so in exams too, they are not going to write the actual this thing paper like that. They are not going to make the actual to do. Maybe find like if the answer falls within this range. So we also got the covariance to be the correlation on the calculator to be this. Zero point 0.7396. So you see, you can just use the calculator to skip those plenty things that we did, right? The only way you have to continue it with your mechanical skills is computing for the standard deviation for the portfolio, right? And that is what you are going to use in here. So basically, that is it up to this thing, right? Hope it's okay. So with this, let me change. So we are going to get around the same standard deviation. It will not be that much. So let me change this one to covariance 1571. So let me just do this. So this is what we are going to get. Yeah, when you use the calculator or the 0.27753. So when you find the root of it, square round answer 0.1666. Right, so this is it for uh, the calculator trick that you can use. And you see, it has actually changed some figures there. So it is going to also change here, but it wouldn't do anything. Because when you use the mechanical way, you are going to get different figures because you'll be rounding some figures. But the calculator wouldn't round the figures. But at the end, that's when you want to round the figures, it will round it for you. You get it. All right, so I think I will have to pause in this video and then record another one. So I'll record the next one covering the rest, the rest of the questions, right? So see you in the next video. Bye. This one is also going to change. 7-1. Going to get a different, but it will still give the same this thing interpretation. So it didn't change. 0.9390. Hey, 6939. Then, why not be dynamic? So I'll upload this question one, then I'll come and then solve the rest in the next video. See you. Bye. As far as you see negative, the same interpretation.